When Aviran asked me to give this talk, I had to actually invent it because I was thinking about writing a talk about this general topic for some time now, but I didn't actually have the trigger to start working on it. I consider it a work in progress, so I would appreciate feedback. And what I'm gonna talk to you about is why I think that only in 2014 we started to think about doing TDD properly. I wouldn't go as far as saying that in 2014 we've been doing TDD properly. I would say that in 2014 the penny dropped. I'm going to tell you why. So I'm going to talk about what's between development and design. And so what is design, actually? So is it this? Is this design?
No.
No. No, this is a design diagram, maybe even. Is this design?
No.
No. So Wikipedia says that software design is the process of implementing software solutions to one or more sets of problems. One of the important parts of software design is the software requirement analysis. It is part of the software development process that lists blah, 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 blah. That's also not design. So in Goose, Ned Price and Steve Freeman liken software engineering to growing a biological entity or to gardening. And I really like this analogy because software isn't something you build. Software is something that evolves over time. And our job is not like the job of a structural engineer or an electrical engineer, but it's more like the job of a gardener. Think about how we as a species have evolved plants or vegetables over the millennia, from little things like sour things to today's big tomatoes, for instance. This is the process of software design and software engineering, in my opinion. But if this is the case, if we are nothing but gardeners, where does design come into the picture, right? Because, like, if we think about big design up front, then we think about drawing diagrams and writing software specification documents, and this doesn't sit well with gardening, right?
You haven't seen English garden?
Yeah. So Michael Feather says that when you're programming, you're doing detailed design. If you have a bridge, then the bridge engineer designs the bridge on paper or using a computer today, but then a team of construction workers actually build the bridge. And what we are doing the design. The manufacturing team, the construction team, if you will, is the compiler or the interpreter. We are only the designers, we are the architects. The source code is the only complete specification of what the software will do. The cute boxes in the class diagrams are not a design. They are a high-level view of the design. They are a reflection of the design. And it also goes on to say that there's an artificial line between programming and design, and this causes tremendous waste. Everyone thinks that software is different than other engineering practices, but it's not. It's just that we misunderstood the way that we actually do stuff in software. It doesn't require a completely different approach. It's not different. We thought that coding and testing were not part of the design, but they actually are. They are the design. They are like prototyping. They're like writing a blueprint. The code is the blueprint. So what does that mean for us as engineers? So the code is the design. So if we go on to my opening slide, the difference between development and design is non-existent. Development is design. as we grow our software, a design emerges, okay? And we need to prune this design, and we need to tender and to nourish it, and to make it better. And so we code according to some product requirements, right? We don't decide on our own what we're going to do. We have a design document. But unfortunately, as we grow our software, the requirements change. And sometimes they change rather drastically, right? And often this gives rise to big balls of mud. I don't know if you've heard the term big ball of mud. If not, there's a very nice article, long, a very tiring one, on the internet. But you should read it, yeah. It's very good. I have a link. Here.
All it's so good, we can read it.
Yeah, the slides will be available afterwards. So if the requirements will change, and the decisions that we make early on will have larger effect on the resulting design than decisions that we make later on, right? Because they have more impact, because it's like evolution, right? A mutation in embryo is much more dangerous than a mutation in someone who's 30 years old. So we'd be better off postponing important decisions, important implementation decisions to a later stage, and initially focus on the interfaces, on the big parts, on the APIs. And this brings me to this. When we write a class, we code to interfaces rather than to implementations, right? So the same approach can and should be used when approaching systems, subsystems, modules, whatever. You're always on the outside looking in. And this is achieved when you write a new collaborator, a new method, a new class, a new module, something that you talk to from your current piece of code, you do it from the call site. So you don't just create a new class and think what the interface is going to be. I grow the interface from the place where I call the interface. This is, in essence, outside in development. Now, there's lots have been written in the internet about outside in development and about methodologies, but basically, outside in development is just this. It's just writing code from the call site, from the outside in. We carve, as Sagi likes to say, we carve our way from outside into the stack. And we create a system. And the stack can be, you know, servers, MySQL, and whatever, but the stack can just as well can be two classes. The stack is relative to your definition of what you're currently writing on. Because everything is like, you know, a fractal, like onion rings. Like you go from the outside in. So from every layer that you're working on, the inner layers are a black box that you carve into. So if we follow the outside-in development methodology, we end up with cohesive, loosely coupled systems that comply with the solid principles. Now, that doesn't happen automatically, right? You need to understand what you're doing. You need to practice, and when you write your software, you need to pay attention. And I'm going to give you a bit like some guidelines, but nothing here is something that I invented, right? I took some books and I read the books, and now I'm telling you what I read in the books.
Like a rabbi.
Yeah, but I don't think that it's radically different to what everyone else in the industry has been doing. Just paying attention. One other thing that happens when you code outside in is that it promotes the you ain't gonna need it principle. You don't need it now, okay? So we're creating a class, and this class needs a database, so I'm writing a DAO, a database access object, and I'm writing a create method, and an update method, and a delete method, and a find by query method, and maybe a find by ID method. And what do I need? Do I need any of these? Well, maybe not. It depends on what the class that uses the DAO needs. In many cases, we make the mistake of following patterns that we learned in the past. Like, you know, maybe some people here remember the generic DAO pattern that was very popular a few years ago, and this is bullshit, okay? Because you don't need it, and when you're going to need it, it's not going to be the same it. It's going to be something else. So there's a very nice phrase that's common in Wix. There's no good translation in English to it. It's "הכנה למזגן." So if you transliterate it, it's a preparation for air conditioner. And for those of you who aren't old enough, there used to be the window air conditioners, or the air conditioners that you used to stick in the wall. So you need to make a hole in the wall for the air conditioner to fit into. And many houses in the 90s were built with a preparation for an air conditioner, but then the new generation of air conditioners appeared, and now lots of houses have these niches in the walls that were closed with blocks. And in my parents' house, there are 3 such niches that he used to store vases now, because there's nothing else to put in them.
No, Shai, that's not the thing. The thing is that they built houses with the holes, and then there were no air conditioners, and then they just had holes.
So Itai tells me that they built the houses with the holes, and then there were no air conditioners. That's exactly the case. And then you had to wall up the holes and put something else in the holes because, you know, they were converted into decorative stuff. Never mind. That's not interesting. Anyway, so if you code outside in, you promote the "you ain't gonna need it" principle, or the Yagane principle, and it also keeps your code tight and orderly, because there's nothing in the code that you don't need. In addition, it helps us distinguish between mechanics and semantics. Now, for those of you who've seen the Marius Eriksson lecture that Kfir sent last week, the son of a bitch stole my idea. I've been talking about semantics and mechanics for a long time now, and he just goes on and just steals my idea. But basically, you will understand what's the difference between mechanics and semantics, right? Mechanics are, you know, like how we do stuff, and semantics are what we're doing. Like a mechanic is a DAO, and a semantic is a book repository, for instance. So when we code from the outside in, it helps us focus on the use cases, on the semantics, rather than on the mechanics. And it's precisely the same as coding to interfaces versus implementations. But when you actually think about it, it's about the language, it's about abstractions. Okay, it's about abstractions over indirections. A nice example for that is in P3, where we have a laboratory and not an experiment manager like we used to have in the old experiment system. A laboratory is the semantic. It conducts experiments. Okay, it has a language of its own, and this is abstraction. Okay, creating a layer of indirection to fetch experiments isn't an abstraction; it's a indirection. And when we code, refactoring is what helps us figure out where semantics are missing, because usually you're going to have ugly bits of code that don't look like they belong here. They look like you know, wiring or just, you know, manipulations or transformations. And that when our code isn't very readable, it's a hint, it's a smell, but it's a hint that maybe there's a semantic missing, maybe there's an abstraction missing. Not necessarily, by the way, because not always we end up writing the proper abstractions. Like in many cases, we sin in you know, mechanical abstractions rather than semantic abstraction. In pattern abuse, we have lots of factories and proxies in our code rather than laboratories and, you know, book repositories. What's that?
Laboratory comes with a French accent built in.
Laboratory. Laboratory. Where's Lorraine? So, All the habits die hard. We grow up reading the Gang of Four book. Maybe many of you didn't, but maybe the older generation did. And we grow up on Spring Framework, on Hibernate, and basically patterns and technologies are cool and exciting, and we want to use them. But maybe we shouldn't. Maybe we should first think about what we want to do, and only then think about which patterns helps us solve the problems. And so we need a paradigm shift to help us shake off the older habits of our engineering and pattern obsession, and to shove us in the direction of outside-in development, focusing on the semantics rather than the mechanics. So this is where TDD comes into the picture, and this is why I say that although we've been writing tests for 3 years now, we've only been doing TDD properly for like less than a year. Well, some of us more, like Sagi and Talia, who's been working with him, maybe Itai, but many of us, and myself included, for me the penny dropped much later than I started actually writing tests. So, TDD to the rescue. So what isn't TDD? Let's talk about that, because that's the elephant in the room. Okay, there's a very big problem where people think they're doing TDD, and they say they're doing TDD, but they don't really do TDD because there's a gap of glossary here. So writing tests after production code isn't TDD. Okay, that everyone knows that. Like TDD is test first, but also writing all of the tests first isn't TDD, because that's the exact opposite. That's the other way around, because you're writing tests for stuff that you don't need. Writing lots of end-to-end tests that are tightly coupled to the system's inner behavior also isn't TDD, because then I have lots of tests that cannot be changed easily. They make our system cumbersome and hard to change, and hard it's going to be hard for us to be able to accommodate to changes in requirements that we're going to have. And we're going to have changes in requirements. We all know that. Also, something that we've been doing for quite a long time is writing end-to-end tests, not from the end, but from the middle. Right? When you write an end-to-end test for the server, that's not an end-to-end test. That's an integration test, a component test, whatever. That's not an end-to-end test. Because an end-to-end test exercises the system. And in most cases, the server isn't the system. It's part of the system. So just a brief history of TDD. Basically, and Sagi should correct me if I'm wrong here, but coined by Kent Beck around the turn of the century. I'm not sure if it's the late 90s or the early aughts, but whatever. It began as part of the extreme programming movement in London, but then it spun as its own idea. Many people are doing TDD and not doing extreme programming, don't even know what extreme programming is, myself included. Body of research by people like Kent Beck, Ned Price, Steve Freeman, Martin Fowler, and lots of other people. Brief history of how we've been doing TDD at Wix. In early 2011, if those of you who remember, we created the IT HTTP framework, something that UAV did, to help us test HTTP servers. Up until then, we didn't test HTTP servers at all. Up until then, actually, we didn't have unit tests at all. We had nothing. There were, I think, 2 unit tests in the public server that exercised something that wasn't even used. In mid-2011, we started working on the old mobile project, and it was developed. So it was developed using these tools.
You call that development?
It works. It still works.
It still works.
Yeah, thanks to Dalia.
Great job.
Yeah, in late 2011, we had I had the first experience of properly using tests to write software. We had the public server, and the public server, as all of you know it today, wasn't in existence in 2011. We had lots of, Uri remembers it. We had lots of spaghetti code there. That was like the view controller, which was a class with 3,000 lines of code. And you couldn't, it was not deterministic. You couldn't realize what was going to happen when you started looking at the code. And so we knew that we were actually, when we were deploying the public server, we used to pray. And I'm not even religious. And so we knew that we had to change it, and we knew that if we're going to start fiddling with it, it's going to break Wix, and we're all going to be fired. So we started writing end-to-end tests, actually, for the public. These were written by Laufer, who is no longer with us, and Ori, who is no longer doing QA. I think Doron was involved in the later parts of that effort. And we wrote these tests, and then we started a refactoring process, actually a rewrite process. But as this process went on, we started to carve into the public and replace the rotten parts with, like, I wouldn't say properly designed, but like at least half-assed designed, decently designed code. This code actually still works to this day, so apparently we didn't do a really bad job at that. And I'm proud to say that when I last left the public server, it was, all of the logic was covered by unit tests, which were running in under 2 seconds. So that was a very nice thing, and I think this is part of the reason why public still has very few amount of bugs to this day. In 2012, I think, Sagi joins Wix. I don't remember. Your LinkedIn says 2012, so yeah. And Sagi joins and starts telling us that we're not doing TDD properly and we're not listening to him. And he says, you know, I'm going to do whatever I want, and you know, you do whatever you want. And then in 2014, I think the penny dropped that, yeah, Sagi was right all along. So let's talk a bit about the TDD life cycle. What we do when we do TDD. So we write a test, we write some code to make the test pass, we refactor, and ad infinitum. So when we test, let's think about the first test that we write in a new system or in a new major feature that doesn't have an end-to-end test yet. So we start by writing a failing end-to-end test that demonstrates the first use case. The test is in English. It's not in code, and it doesn't compile. And we examine the test to make sure that it makes no assumptions about any implementation details in the system that we are going to write. The test should be a use case. Then we start making it pass. From the outside in, we carve inside. This is building the walking skeleton, if you read Goose. And if you haven't, please do. So we start making it pass, and we write the simplest code possible to make it pass. We don't think about design here. We think about making the test pass. And this will tease out complexities that we didn't think about, that we haven't considered before. And it's going to take some time. It might take, you know, a week, 2 weeks for something that's a complicated system. That's okay, because this is time well spent. This is time that you're not going to spend later on integration and on deployments, because if you tackle everything early on, then you're going to tease out the problems, you're going to deal with the problem, handle the problems, and when you decide to go live, you just deploy, and it works. And then refactor. When we refactor, we examine the code we just wrote, and any code that might have been affected by code that we just wrote, because maybe previous assumptions changed. Of course, this doesn't pertain to the first use case because there wasn't any previous code, but yes. So we determine solutions to these smells. We identify the smells, we determine the solutions to these smells. Many times these are design patterns that we want to put into place. So design patterns are used to solve code smells. The way that we achieve this is by refactoring, by actually following the guidelines that Martin Fowler has detailed in the refactoring book, or by using IntelliJ if you want to do a refactoring that's simple enough for the Scala plugin, or if you're doing Java. And in iteration by iteration, a design for our system emerges from this work, from the refactoring cycles. And of course, this needs to be both in the micro and in the macro, because design is both in the little bits and in the big bits. Now, we sometimes forget about the refactor step, or we don't give it its due respect, whether it be because of time constraints, the product wants more features, or we just simply misunderstand what does refactoring mean. Now, up until a few weeks ago, I admit I haven't read refactoring, but to make this presentation, I actually had to read the book, just the first few chapters. It's highly recommended, because it will make you understand, or make you better understand, what it means to refactor and what refactoring doesn't mean, which is much more important. And refactoring, it's not an optional step. It's at least as important as the code step. Actually, you could probably write code to generate the code to make a test pass, but you could probably never write code to make a refactoring, because refactoring is the art of software design, of software engineering. It's identifying the patterns. It's identifying the code smells. This is your job. Refactoring is your job. It's our job. So Martin Fowler says that refactoring is a process of changing software systems in such a way that it does not alter the external behavior of the code, yet improves its internal structure. It's a disciplined way to clean up code that minimizes the chances of introducing bugs. In essence, when you refactor, you are improving the design of the code after it has been written. Again, this is design. This is what helps design emerge. Okay? If you accept the premise that design emerges, then this is where design happens. Now, TDD urges us to code in small increments, in small iterations, and effectively it holds us back from making drastic changes that are not necessary or not yet necessary. And as a result, the refactors should be relatively small. And this is done both for the production code and the test code. You gotta remember that the test code is code, and code needs refactoring, code needs design. Your tests have design. Your tests should have abstractions. Many people write tests that are not readable, and then when they come back to the test, a couple of months later, they have no idea what the test does. So a test itself should be tightly coupled to an interface. It can be called a driver, an abstraction layer, whatever, it doesn't matter. A test is a small, readable, English readable set of steps that exercise the system under test, and that's it. Whatever it's an end-to-end test or a unit test, it doesn't matter. The test sees the system that it's talking to via an interface that exposes a semantically meaningful set of commands. So how do we start? How do you start the TDD process? So we are a new team and we want to build a new product. So we sit with the product manager, we go over the product requirements. It can be wireframes, it can be a software requirement document, God forbid. And we go over the requirements as they are currently understood. This is important. And we enumerate them and we prioritize the features and we decide what's going to be the first feature. It's going to be first couple of features, the first few features. If one single feature doesn't make sense, it doesn't matter. But it's the first feature, okay? It's the first thing that we do, and we create a working skeleton for this feature, following the process I just enumerated, and we follow the rabbit hole and we see where it takes us, and you're going to be surprised where it takes you. Many hidden issues that you haven't thought about will surface now. And it's also going to affect the product. So it's very important that we involve the product people in the feedback that we get from the test, from the working skeleton. So if we think back about the TDD lifecycle, it's not test code refactor. It picks the most important feature right now from the backlog. Test code refactor, test code refactor, test code refactor. Okay, we're done. Pick the most important feature, test code refactor. It's like a wheels within wheels thing, and it's a way of life. How do you do that? How do you adopt this way of life? So the first thing that I want to tell you is one of the things that really helped me adopt it is cultivating a beginner's mind. So when you are a beginner at something, then you don't know anything, and you're open to learning stuff, and it helps you deal with criticism. It helps you deal with feedback from the tests. It helps you disregard stuff that you learned in the past that's no longer relevant, like pattern obsession, design patterns that are not relevant in here. It makes you humble. A beginner's mind makes you humble. So I would really recommend that all of you always cultivate a beginner's mind. And think about your work, your job as a learning experience. Because when you do that, it's much more easier for you to shake off the habits and our pride. Okay, we are engineers. We know patterns. We spend a lot of time learning what we know, and we are proud of it. But pride also makes us, yeah, wrong. Pride makes us wrong. Pride makes us make mistake. So let go of your ego. Okay, it doesn't serve you, and it holds you back from accepting feedback, be it feedback from the tests or feedback from your colleagues. You gotta let go of your ego, and only when you let go of your ego, you will really understand what it means to TDD. Because TDD isn't a methodology, it's a way of life. And you still ain't gonna need it, okay? Remember it. You're not gonna need anything that you don't need right now. Don't do it. It's like, it's really important that you always keep, you ain't gonna need it in mind. And lastly, remember that abstractions belong in a test at least as much as in production code. Because again, ideally, you should be able to take a system, delete all of the production code, and recreate it from the tests. And it should work exactly the same. And you can only do that if the tests are readable and meaningful and are abstracted properly. So that's it. Questions? Okay, thank you.